Okay, for the introduction, I will talking about simple linear regression, which is a method to use, understand, and predict the relationship between two variables. For example, we might want to see how the change in education level affect income. This method uses a straight line to show the connection between the variables, and the equation is usually written as y equals to beta O plus beta 1, where beta O is starting value and beta 1 is show how much y changes when x increase. We also use a scatter plot to see the trend and a Pearson correlation value to measure how the strong relation is. Okay, in this project, we use Microsoft Excel to analyze data and see how the energy use change over time. This also helps us understand the pattern and even the predict future energy use.
Good evening, Doctor. My name is KUMAR and So first, I'm going to explain what the data requirement of our project. We have been collected of 30 data of renewable energy consumption of US from year 1950 till 2023. So for your information, Doctor, year has been chosen for the independent value and renewable energy consumption is chosen as a dependent variable values. And we have collected data of renewable energy consumption of US in a quadrillion, which is it's a so many lot of value. And the highest value is on 2023, which is 8.2 for quadrillion. And so the next part is software selection. For our project, we have selected Excel as our main software tool to calculate all the values for our upcoming presentation. We have collected mean is minimum value, maximum value, average, and standard deviation by only using Excel. Basically, Excel is like it's not a easy tool to use, but if we understand very well, we can use this Excel very wisely, just like we did for this our project, for our statistic project. And we also we have also provide some values of regression coefficients, p value and r squared value. We also found the value for Pearson correlation coefficients. Overall, that Excel is an appropriate software for this group project actually, and we did very well for this Excel usage. So that's all my point, Doctor. I pass to my next team.
Hello, my name is Edward Rush and my metric number is CE230105. Okay, today we want to see the result. Okay, for the A, the year of the minimum we get is 1950 and the maximum we get 2023 and the mean we get 1986.2667 and the standard deviation is 22.0124 and the renewable energy conservation is for the minimum is 1.79 and the maximum is 8.24 and for the mean is 3.8697 and the standard deviation 1.8943. Okay, for this we can use the calculator to get the data and just inside the data on the calculator and the press statistic will show the minimum, maximum, mean and standard deviation. Okay, for the B, plot the scatter diagram and determine the linear regression line. Okay, for the taxi X, we get we use a year and the Paxiva is the renewable energy consumption and the line is going to upward and the R square we get 0.8781 Uh, for C, assume the linear relationship. Use the least square method to find the sample linear regression model. Okay, for the XY, we'll get 1137.4027, and for the SXX, we'll get 14051.8667, and SYY we get 104.0579, and V1 we get 0.0809, and V0 we get negative 1.56.8193. For the SSE we get 12.0420, and MSE 0.4301. Okay, later my group mate will show the manual calculation. Okay, okay, to the details, check the signification alpha 0.05, the simple linear regression model in C. Okay, let's see on the Excel we get. For the multiply R, we get 0.9370, and the R square we get 0.8781. This value is same with the plot scatter diagram. Okay, R square I mentioned 0.8781, so it's a same. So the summary output is correct, and the T start we get statistic we get 14.2029, and the p value we get 2.53. To check if the regression model significant, we observe if the signification f value from the ANOVA table is far from the zero. Using the regression analysis function in the Excel, we get the R value of the 0.9371, which show a positively weak linear relationship, and the p-value of 0.2.53571 E dash 1714, which the more than 0.05, and showing the relationship between year and renewable energy is statistically significant. Thank you.
Alright, so I will continue the presentation. First, my name is JIAN, number 3 is CE23007. So now I will showing you the interrupt, the meaning of the interrupt, and also the scope in this problem. So we can get the interrupt cost at the y-axis when the independent variance renewable energy consumption, which we reach zero, and the value is negative 156.8193. So this means when the renewable consumption is zero, the predicted value of the dependent variance years is the value we get. And the next which is the scope, and we get the value is 0.0809. So which means that's for every additional contribute BTU of the renewable energy consumption, the critical year increased by that value. So next is we test the hypothesis for by taking the 5% level of signification, but we already rejected because new hypothesis there is enough evidence to support the claim, so we already reject. And the next is the compute the Pearson correlation coefficient R, and also the its meanings. So this is the formula, and we get the correlation is strong positive linear relationship between years because the value of Pearson correlation is 0.9. So which is between the 0.5 and the 1. So it means the strong and positive. Next is the compute of coefficient of determinant R2 and interrupt its meanings. So this is showing the coefficient of determinant, which is the R, the formula, and we get the value is the coefficient of determination is 0.8843. So that is showing a higher R2, R square root 2 implies a better fit and also not worse. So a low R square does not indicate a benefit. And the last is we also discuss the effect of outliers data point on the coefficient of determination. So the Pearson correlation coefficient R equal 0.9406R, and also the same an indication that's showing very strong positive linear relationship between years and renewable energy consumption. So this is mean that as a year increase, and also consumption of renewable is increased in a strongly predictable manner. So that the higher value of R suggests that the linear model is good and also fit for the data. So that's all. Thank you very much.
Okay, for the manual calculation, first we have to identify the oil submersion value. Okay, for step one, we find SXY. For this, we have to use summation XY minus 1 over N multiplied with summation XI summation YI. So for this, the value is 1137.4227. Step two, we find SXYX. So the value is here. We've used formula summation x square minus 1 over n multiplied with summation x square. Step 3, we find SYY. So for this, the formula is summation y square minus summation y square minus summation y square over n. So the value is 104.0579. Step 5, we find eta 1. The formula is SXY over SXX. So the result with value is 0.0809. So for step 5, we find beta of 0. This we use y minus beta 1 multiplied with x. So the value is negative 156.8193. Step 6, SSE. So the value is 12.04. And step 7 is MSE. So the formula is SSE, which is we find in step number 6 over n minus 2. So we input the value. The value for MSE is 0.43. Okay, for conclusion, our project successfully utilized simple linear regression to examine the relationship between year and US renewable energy consumption using 30 data points from 1950 until 2023. We established a linear regression model with a slope of 0.0809 and a intercept of negative 156.8193, and the strong Pearson correlation coefficient, which is R equals to 0.9406, and coefficient of determination, which is R square equals to 0.8843. Confirm a statistically significant positive linear relationship between at the 0.05 level. While our model provides valuable insight into historical trends and reinforces the increased utilization of renewable energy, it's important to acknowledge that some unexplained variation and potential layers might the limit is productive accuracy for future values. Okay, that's all for this project presentation. Thank you.